See, normally what happens is KGDB. Okay, in KGDB, what happens is you'll have a target system. Okay, so in the target system, you have a kernel running. Okay, so I can enable the KGDB on this. You assume if I enable the KGDB. Okay, so what will happen is it will be monitoring for the it will be so moment you start a KGDB, moment you start the kernel, right? So there are two ways of stopping the kernel. Either I can tell to stop the kernel on boot. Assume that I want to debug the kernel from the boot. I can configure that I want to debug the kernel from the boot also. That is also possible. Okay. So else I can stop the kernel at any point of time and pass the control to the KGDB. Okay. But in KGDB, I need to tell where the KGDB should need to run, whether it need to run on the serial console or where it is. Okay. Normally people use serial console for this. So it will run on the serial console. Okay. So the host system which want to debug, okay, will connect via the serial port. Okay, and he will connect to the system. Okay, and he will take the control of this kernel. Okay, same like your application. Okay, he'll take the control of this the kernel and he can continue debugging. Okay, here the GDB only will be running, something like GDB or any debugger will be running. Via GDB, you will take the via serial console, you will take the control of the system and remotely you'll be debugging on this particular host and figuring out what exactly happens on this particular system. Okay, so all these things will happen. Most of the times it happens via serial, but to enable this, we have to configure the kernel for this particular purpose. Okay, so this we have to configure. Okay, so we will see how to do this. Okay, so what I've done currently is since I need a two system to do it. Okay, so since to simulate this KGDB, I'm using QEMU. I'm enabling KGDB and I'm showing it. So we will see what all kernel configurations we have to do for the KGDB. We'll try to understand now. Okay, so I will just show you that now. So let us configure the system both for a KGDB and other things. Okay, so now, so let us go to this QEMU. Okay, so before that, let us call the configuration part. Give me a second. Yeah, let us shift end. Okay, paste and let me clean it. Okay, so it is done necessary cleaning. Okay, so we will see what all configuration need to be done as a part of this KGDB. That is what we will check out. Okay, so for that one thing what we have to do is we need to go to menu config and configure the kernel. The process is same for any architecture, it doesn't matter. Okay, so I'm the whatever steps I show here, I'm just simulating it here, but same thing will work on any system to system also. Okay, so I will just do a make menu config. Okay, so now in this particular thing, if you want to enable the K config, right, KGDB, right, there are a lot of things which we have to set. We need to come to this thing. Okay, so one of the main thing what we have to set is we have to enable the debug info. Okay, then we have to enable the GDB scripts. Okay, for kernel debugging. Okay, then after that, once we are done with this, okay, so this we are we are enabling the debugging feature for our kernel. This is one thing what we need to take care. Okay, then we have to enable this magic. If you remember, if magic sys request key I told, right, we have to enable this feature. Okay, and we have to enable this magic sys request key over the serial. This is one main thing we need to do. Okay, and we need to enable the kernel debugging features. These are the main things that is required for KGDB. Okay, so then after that we have to enable the KGDB. So for that we will go to the KGDB thing. Okay, so we have to enable this KGDB. Normally it will be disabled. We have to enable it. Okay, so then if you go inside it, okay, so you need to tell that KGDB should use the serial console. We need to tell KGDB will work over what. So I'm telling here KGDB will work over the serial console. Okay, and after that I'm telling that it should use the internal test suite. In case if it wants to test something, it will use some internal test suite. Okay, so then once that is done, so what we will do is we will use KGDB to KDB front end. Okay, so basically I'm enabling the KDB also. Okay, so I'm enabling KDB also. Okay, so and after that, once it is done, so basically I'm enabling all this thing. So with this particular thing, what will happen is my KGDB will be enabled and it will be ready to run. Okay, so now we have enabled all the features. So basically you have to do this particular thing. One thing is you have to enable all the debugging features for your kernel. Okay, so via this particular you need to enable this kernel debugging. Okay, then you need to go to this kernel option and you need to enable the debug info for your kernel, because without debug info then your GDB can't make any sense. Okay, so once we have set the necessary parameters. Okay, so then we have to come out of this. Okay, so now we have to build this particular kernel with this particular features. Okay, so let us wait for this. Let the build be done. Okay, so once it is done, then after that I will show you how to take the control of this kernel via KGDB and debug it. Okay, so let us wait for it. So it will be done by that time. Okay, so and one thing before that I will show you few options of what you have to set for debugging it. Okay, so the main things what we have to set is once we have taken the control right of that particular thing. Okay, so we have to set this options for debugging. We need to append the following parameters to the kernel. Okay, so those parameters are I will just we will just put here on the. So we have to set this parameter KGDB wait. Okay, and KGDB doc is something which we need to enable. Okay, so we will see in the kernel parameters what does this mean. Okay, KGDB doc. This is the one. Okay, so we are telling on which console the KGDB should run. Okay, in case I tell that the KGDB is running on the serial console. Okay, so I will pass the serial kernel parameter something like this here. If you see here, I'm telling that KGDB doc. I'm telling this KGDB doc. Let me zoom it so that you can see it. Yeah, so this in this I'm telling that KGDB doc basically. Yeah, I'm telling that it should work on this serial console at this particular baud rate. So this particular point is done now. Okay, and I'm telling KGDB wait. Moment I put KGDB wait, what happens is my kernel will not run completely. Okay, so it will wait for the KGDB command. Okay, so we will just see that part also now here. KGDB wait. We will look at it here. Okay, so it will stop a kernel will stop execution and enter the kernel debugger. It will enter the kernel debugger mode. Okay, so your kernel will not run and it will stop and it will wait for the some debugger to connect for me. Okay, so normally if you do an application debugging, what you do is you assume GDB, you load a program to GDB and the debugger immediately stops. So the next step what you do, so you put a break and unless you tell to run, nothing will run. Okay, in the similar way here also the moment I tell KGDB wait, because now this debugger is enabled inside the kernel. Okay, so I need to pass one option is I need to tell via KGDB wait, I'm telling that my kernel should stop. Okay, so kernel should stop execution. Okay, and enter to wait state and it should wait for the kernel debug and it will trigger the kernel debugger. Okay, why KGDB doc, I'm telling that KGDB will work over the console. Here I'm telling the kernel to stop and wait for the debugger to connect. In this particular option, I'm telling my system should wait. All the KGDB commands will go over the serial and what baud rate. So these are the parameters what I will pass to my particular kernel config. These are the two things which I have to pass to my kernel config. So moment I pass it to my kernel will be ready to enter into KGDB mode. Okay, so it is building. Okay, so just let us wait for this to complete. Then after that, we will try it out. Okay, so the reason is we could have tried this on our VMs also, but the problem is so in some of the systems, right, we don't get the stable Linux kernel to build. Okay, with the KGDB option. So that's the reason I just took the QEMU to simulate this. So the step is same. If you then later point of time you can try the same thing actually. Okay, so just give me a second. Let it do. Let it build. Okay. So these are the two important parameters. And if you see here, there are a lot of parameters, command line parameters, which you can pass to your kernel. If you have time, you can just go through this whenever you get time. Okay. So these are all some important parts which you should know. There is something called debug equal to. Just a debug, I think. It is not debug equal to, just a debug. Where it is. So this will enable the debug for the kernel. So moment you pass debug option debug, it will enable the kernel. So basically like that, there are a lot of options which you can pass to your kernel. These are all the boot parameters, command line parameters, which you can pass to your kernel. So which tells how your kernel should behave. Okay. So you can just have a look at all the things. Not many things are not important to us, but few things are very important. Okay, like whatever I told about that, and you even you'll have a boot delay basically. Okay, so basically it will tell. So basically after boot, basically how much time it should wait for print K to appear. So all those things you can configure. Okay, so like that, there are a lot of things here, and even there's option for debug also. We can just look at, and you can tell where your console, basically whether all the messages should come to serial port or somewhere else. You can configure basically. Okay, so you can configure where the serial messages should come. That also you can do it. Okay. So crash kernel is something what we saw here. If you remember, we gave the crash kernel, right? So crash kernel is for crashing it, basically for crashing it, so that the KDM can use the locks. So that also can pass as a parameter. Okay. So this is one thing. Okay, this is the one I told, enable debugging. Okay, so the moment you pass debug as a command line parameter, it will enable the debugging feature in the kernel. So all the debug messages, you'll get all debug messages and they will not be disabled. And there is one more thing called quiet. If you pass option quiet, you will not get any messages on the console. Everything will be stopped. Okay, so that is one thing. And after that, like that, there are a lot of configurations. You can have a look at this basically. Okay, so all of these things are very important and very critical. Okay, so you can have a look. This is very important basically. Okay, so like this, and even if you can configure the f trace, you can pass the f trace details also what you want. So like that, there are a lot of options. So this list is very huge. Normally we set was pass only few options, but there are thousands of options which you can pass to the kernel while it's booting. Okay, few are architecture dependent and few are very generic. Okay, so you can just see what you want to pass, and based on that you can pass it. Okay, so let us see if the build is almost getting done. Let us wait for this build to be done. Okay, so this way you can set and get all the information from this basically. Okay, so if you want, you can do nfs mount while the kernel boots also basically. Okay, nfs root, where I'm telling that the root fs is not on my local directory, but the root fs is there in the nfs. Basically in this subsystem, normally all your root fs, because if I see the previous exercises, right, we knew that we know that rootfs is the one of the main root file system which is required for the kernel to boot. Always kernel needs a rootfs. Okay, so that is what we saw, and we built all our rootfs using busybox. Okay, in case you don't want the rootfs to be in a local file system, but you want a rootfs to be on a remote server. Okay, on the basically on the remote server, on the remote file system. Okay, so those things can be mounted by nfs root equal to option. Okay, so the moment you pass this option, so what will happen is your kernel will not take a file root fs, will not fetch a root fs from the local file system. It will go to this remote server, and it will take the file system, it will take all the folders from there, and it will boot from using that mechanism. Okay, so that also you can pass this. All these things are very important basically. Okay, so like this, there are a lot of information. You can just go through this, and you'll so you will get a more detail what all things you can play around with the kernel whenever it is required actually. Okay, so all these things are required. Okay, so did it happen? Just give me a second. It is just going on. Let me see what happened. Yes, it's building. Okay, it's almost a building. Let us wait for a few things. Yeah. So let us do it. And before that, let me copy the kernel command line parameters and keep it ready. And we will be discussing on that command line parameters. So we know what are the command line parameters. We saw the few command line parameters, but something that is required even for this basically. Okay, so we will just look at those. Okay, so anyhow it will come here. Okay, so I will just do it here. Okay, so like this you can pass. So if in this case, so what I'm doing is here, I'm using QEMU to start this VExpress board, what we have done till date. So I'm reserving a memory of 512. I'm using this particular DTB for to boot. Okay. So I'm using the kernel, which is available in this folder. Okay. So I've already have a rootfs. I'm using that rootfs to boot. Okay. And I'm using KGDB because I want the kernel to wait for the GDB commands. So this is the one. Okay. So I'm telling that this particular GDB should be available on this particular serial port, because VExpress board serial port is nothing but default serial port is TTYA MA0. Okay, so I'm passing that. I'm also telling what baud rate it should run. Okay, so I'm telling that rootfs should be on the RAM, and I'm telling that it should use the RAM disk to start. Okay, so I'm passed all those things, but since it's a QEMU and this is not a real board, so what will happen is I need to route all the serial messages to something. Okay, so that is the reason what I'm telling to this guy is I will route all this message to all the serial message over a TCP. So I'm using QEMU. QEMU is a mechanism where it will collect all the serial messages from this guy and it will route to TCP. So what I'm doing is I'm routing all these messages on TCP, and if this one we can specify the IP address. If I don't specify, I'll take the local host, the center one. Okay, then after I'm specifying the port number, 1234 is the port number. What I'm passing, I'm telling that this will act as a server and it will not wait for anything. So this is the after I do this, the serial port will run on my serial basically on my as a TCP IP. It will propagate all the message on a TCP IP port on the port number 1234. Okay, and so this will be ready on this TCP IP port, and it will be collecting the message. So it is like communicating on this particular serial port. Now this TCP IP is a bridge between this virtual real serial board. Okay, so once once my kernel builds, if I pass this message, now I will be able to take the control of my board using this, and I'll be able to debug. Okay, just let us see if the build is done. Yeah, it's almost at the end. It's almost come at the end. Okay, so let us do that. So it's almost come at the end. Okay, so once I run it, then my system will be able to run. Okay, so let us see once it is done. By this we can see it. Okay, so any doubt till then, till the kernel is building? Any doubts you people have? Any doubts actually?
Here the TCP and you're passing the port number 1234, right? So
Yeah,
it is
yeah, right.
already enabled by that time when it is launching. So
It will launch. QEMU will launch this actually. It's a parameter to the QEMU.
okay, so it will if you're passing like this, so internally it will configure
Yeah,
the
so
port
what
number.
it will do is QEMU will start one server. Basically, it will open the port and so things. Basically, it will start a small server. Okay, on this particular port number and particular IP address, and it will use an TCP protocol. Okay, then after that, all these messages which is coming this virtual board that is VExpress on this particular serial port, it will pull all these messages and it will drop everything on this particular port number. So whatever
Okay.
comes on this port number, it will all the messages it will push via this via it will the server will fetch all the result and it push to this serial port, virtual serial port, the serial port on this virtual device.
Okay. So in the real scenario, we need to configure all these things.
Yeah. So real scenario, it is nothing. You don't need this message at all. In the real scenario, you don't need this. Since I'm using a QEMU, I'm using it. You don't need this basically.
Okay.
Real
So
scenario means then, hello.
A real
using
scenario means I'll tell you what I mean. Okay. So assume, for example, etc grep default grep. This is what I'm booting my kernel.
Yeah.
Okay. So assume I want to debug my existing Ubuntu.
Hmm.
Okay. So what I need to do is assume the KGDB is already enabled on this. Okay. So what I need to do is I need to take this message. Okay. And I need to copy here. Okay. So then after that, normally this all PCs will have a serial port on TTY-S0. I need to do this. Okay. And I need to reboot my system basically.
to access, I mean, same like kind of minicom, or I mean the
You
serial.
can use minicom also. That is also fine. Normally, since GDB works on the Linux system, right? What you can do is just to connect. See, I will tell you how the interface works like. I think this will give a clear picture. Okay. Now you have a kernel here. You have a remote system here. Okay. So this is your remote system. Okay, where the kernel is running. This is your target system. Okay. In the command line, I have passed KGDB wait. Okay, and I passed KGDB doc. And I've told it need to wait on the messages on /dev tty s0, and I've given the baud rate 115200. Okay. Now assume this is tty 0 port number, which is nothing but it's a COM1 on that particular PC. Okay. So in this serial port, I have a remote PC here. Okay. So assume this system is Linux. Okay. It is coming here. Okay. So what I will do is I will start GDB here. And this also has, let us assume, COM1. Okay. So now I am telling that I should connect to target remote serial port. So via GDB, if I tell that now I will give an IP address, instead of giving an IP address, I will tell I need to connect on I will connect on so and so port. So all the messages will come on the serial port. Okay. Since this serial port is connected to this guy, these messages will flow over to this guy. Okay. So this guy will wake up, know that the message has come to him, and he'll respond back to that message back. Okay. So obviously this will come to GDB again. So GDB will get the data. Okay. So whenever it needs other data, it will push the messages on the serial port. So this guy will receive and he'll respond back, and that messages will come back by serial port to my GDB. Did you get this part?
Yes, yeah.
Okay. This is the way it is. Okay. So normally, so you know how to connect to a remote system via GDB, right? Are you aware of that part basically?
No.
Have you worked on this GDB server mechanisms basically? Okay, I will just tell you basically. So basically, I think you people would have missed actually in the advanced C sessions. Okay, so basically there is something called client and server mechanisms. Okay, so where using you can connect from GDB, it is not necessary that you should run the code on the local system. The process can be running on some other remote system via GDB client. You can connect to that remote system and debug. That is called remote debugging basically. Okay, via GDB you can do it. So in this case, my normally the interface will be Ethernet. Okay, so in this case the interface is serial. Okay, so the message is, give me a second. Mm, give me a second. Remote, you need to pass something like this. Just give me a second. I will show you. Yeah. So target, okay, target remote, okay, fine. Okay. Yeah, it will be something like this. Yeah, I will just share it with you. You can just, can you see this now on the console?
Yes. Yes.
Yeah. See here, I will assume that normally there'll be a GDB server. In my case, whenever I tell KGDB, right, a KGDB is nothing but a server. Okay, and that server is pushing all the data on the serial GDB serial using serial protocol. It is pushing the data. You can also push the data on the TCP connection. Okay, or you can push the data via the serial line. Okay, so my GDB, which is available locally. Okay, so what it will do is, so that is the reason while connecting, we need to tell where it is available. Okay, so in this case, when I'm connecting, right, I need to tell target remote the IP address where it is running, or else I need to tell which serial port is running. Okay, so in my case, the serial port is nothing but /dev ttys0. I need to tell target remote /dev ttys0. Moment I tell this on my remote system, it will be able to remotely connect to the GDB server and it will work. It will be something like this, basically. So if you see here on this particular system, here it is running on /dev tty s0. So basically tty s0, it is the protocol is running by KGDB. It's passed via this KGDB dock. Okay, it's docking on that particular thing. When I start GDB, since I need to connect this, since this application is what I am debugging, is not available locally, it's available remotely. In GDB, I need to pass a command called target remote. Okay, and target remote will indicate to the GDB telling that I'm not debugging locally, but I'm debugging remotely. Okay, now remote part is two things you can pass as a parameter. I can pass an IP address and port number if it is a TCP kind of debugging. In this case, it is serial debugging. Okay, so I need to pass target remote, okay, the device file where it is available. So in this case, I should tell /dev tty s0. So the moment I do it, since this COM port is also visible on this Linux as /dev tty s0, so it will directly communicate on this port. Okay, so since whatever messages comes on this, since it will easily go here, and whatever comes on this will easily come back to this port number. I am not worried what is this connected to. Only thing is I need to make a physical connection via UART cable from here to here. So after that, the data will be flowing from there to here and here to there, and the communication will be happening as per the GDB protocol. Okay, did you get this point actually?
Yeah.
Okay, so like this, you can do GDB remote debugging at any point without any issues, and we can get all the information from the remote systems. Okay, so we will see this once this is built. I will show the example. So in this case, since I'm simulating, right, this real port is not available in my case. Okay, so what I'm doing in my case is for this particular purposes, just give me a second. Okay, so what I will do in this particular case is now, in this particular case now, it's a virtual device, it's a QEMU. Okay, so now this particular subsystem is a QEMU. Okay, QEMU is hosting my board. Okay, so the board which I'm running is inside, which is called vexpress v9. Okay, and this is exposing the COM port, whatever I talked about, tty am a0. Okay, this is the port that is available. Okay, but this COM port is not visible to outside world. Okay, so what I'm doing is via that, so QEMU provides an option where I can route all this serial port on TCP IP. Okay, so I'm this when I tell that to pass minus serial option and I tell it everything should go on TCP, all these messages will be routed on TCP server which is running inside. Okay, and it will expose the port number 1, 2, 3, 4. Okay. Now what I will do is on the remote system, it is something like serial to Ethernet converter. So this has become like serial to Ethernet converter. QEMU is converting all my serial data to Ethernet data, and it's pushing on the Ethernet line on the port number 1234. Okay. Now I GDB. When I start GDB, and when I'm connecting to this remote system, I should tell target. Okay, remote, and I should give an IP address of the system and the port number. So the moment I do this, everything goes via the TCP/IP mechanisms. Okay. So this server will translate back to the serial message and it will push all the data via serial to this guy. Okay. So this is the mechanism what we are doing in case of QEMU. Okay. So QEMU is only job is passing all the serial Ethernet data what comes via the server and translating it to serial, and whatever serial data it comes, it is translating to TCP/IP and it pushing on the line. Okay. So data is not getting changed, data is same, but only thing is it will form a Ethernet packet frame and it will push over the Ethernet network. That is the only thing. Okay. So this is the network this is the kind of configuration what we'll be working now. Okay. So let us see the build is done now, and we will check out if the build is completed, and we can so build is done. Okay. So now the build is done and we know that this is a configuration what I am passing. Okay. So I will start a system with this particular configuration now. Okay. Now if you see, if you wait any number of times, your kernel will not start, and it should not start also because it is waiting, because I passed KGDB wait as an option. Okay. Now it is waiting for the kernel to start. Okay. So now what I will do is I will using a remote GDB. Basically I will use the GDB and I'll connect to that. Okay. So I'm simulating the connection part. So what I will do is I'll go to this Linux kernel, and there is already a GDB, a cross compiled GDB inside this folder. I will use that. Okay. So I will start it and I will tell where is the kernel available. Kernel is available on this thing only, and I will start it. So it is reading the simple and everything is there. Okay. Now I need to connect to that target system. I will tell target remote. Okay. Then I will give the IP address 1234. If I don't pass anything, initially it will assume as localhost. Okay. So I will do this. So if you see here, it is connected. So if you check out here, the connection has been established with this particular device. Okay. So it's got connected. Okay. And it is already available here. Okay. So what I will do is, if I want to debug, I can do single step one after the other and I can continue. Okay. So let me do a different scenario now. I will just run continue here. Okay. So the moment I tell continue, my system starts booting here. If you see here, this is my system booted only after I gave continue there. Okay. Now assume after coming here also I want to stop into the kernel. Okay. So what I can do is I can tell echo G. G is an option where I pass to sys request to stop the kernel. Okay. So I will tell proc sys request trigger. So the moment I tell this, it gives the control back to my GDB here. Okay. So it given the control back to my GDB here. If you see here, it gave the control back. So it is telling how many threads are running. Okay. So I can get all the information or info threads. Okay. It tells how many threads are running. Okay. So it is giving all the information about how many processes are running, all the information it is giving. Okay. So using backtrace command, I can check out at that particular point of time what happened. Because since I gave the command sys request command, it stopped at sys request. Okay. Now I can give breakpoint wherever I want. Okay. If else kernel also provides some few features which you can use via LX command. Okay. So assume I want to check out see what is the command line that was passed to this kernel. I can see this. This was the command line that was passed to kernel. Okay. Then I can check out how many CPUs is available on the kernel. Okay. So this is four CPUs and but only one active CPU at this point. Okay, so then after that, assume that I want to do some FTD dumps basically. Okay, so that is also possible. Okay, then I want to check out what all modules are loaded. That there is no module loaded at the system. Okay, then I want to check out all the symbols that is available on the system. There is no symbols available. Okay, so I want to find out what is the version of the kernel version that is loaded. So this is the kernel version. Okay, so then I want to check out what are the mount points that are mounted. Okay, so these are the only two mounts points that is lower mounted on that particular system. Okay, so I want to see what all process is running at that particular point. Okay, so I can find out that this is the kind of process that is running on that particular system. This information also can be got. Okay, so all these things I can find the memory details also basically. Okay, so it gives complete memory details telling that what memory is available in that part, what section. So everything is available here. Okay, so basically it gives a complete information about the memory part. Okay, so this is also available here. Okay, so now and after that I can also check out what is the IO ports that is visible. Okay, so then after I can also do list checklist. Okay, so basically all these things are possible using this commands. Okay, so now after that I can see the D message also. Assume that I want to see the D message. After stopping, I want to check out what are the D messages that has come up. Okay, so I can also see the D message of that particular kernel. If you see here, basically if you check out this, it tells that it's booted so and so 5.1.16 kernel. That is what, and it's an ARM7 processor which is running on this particular board. Okay, now and after that, what has happened is it has started all the things, PPIT and all those things has particularly started. Okay, so everything has started and we can debug whatever we want. Okay, so assume you want to debug some particular point, you can set a breakpoint also, like schedule. If you want to just give me a second. I think it is sung. Something happened. Give me a second. PSX. What happened to that particular thing? GDB. I wanted to put a breakpoint, but it stopped. T2/S0. No. Yeah, this is running on this particular thing, but it went to sleep state immediately. Yeah, this is the one. It is running state, but what happened? Yeah. Okay, fine. No. And assume that I want to put some breakpoint as SHDUL schedule. Okay, so assume that I want to look at the scheduling part of the code, what really happens while scheduling. Okay, so we will go to the source code and look at some scheduling breakpoints. Okay, so what we will do is cd kernel. Okay, we use schedule because all the scheduling information is available in this particular thing, schedule. Okay, so we'll go to core schedule core.c. Okay, SHDUL schedule. So we can see even the GFIS values also I can print and check out what is it. Okay, so print GFIS GIFFIS. Okay, so I get to know what is the GFIS at that particular point. I am not increasing anymore because I've taken control over the board. So I get to know what I can print all the global variables and I can so basically I can debug everything. Okay, so for that this is the one, and schedule I need to schedule current. Okay, give me a second. Grep minus schedule. Yeah, schedule flush, schedule prepare. Schedule, we need to schedule idle. No, no, not this one. Let us assume we'll put a breakpoint. Schedule delayed, not this schedule idle. No. Let us fix some breakpoint. Where to put the schedule time mode is not the right place actually. Okay, let us put some breakpoint in some other location actually. Timer. So basically, you can put breakpoint wherever you want. What I will do is I'll put a breakpoint at schedule underscore timeout. Okay. So sorry. Break schedule underscore timeout. Okay. So then after that break VFS underscore write. Okay, so it is so when somebody does a read and write operation also it will stop. I have given a breakpoint even for that also. Okay, so let us continue now. Okay, now immediately if you see the schedule breakpoint, some scheduling is happening, so that is the reason this is getting called. So if I see here, I'll get to know that basically some thread is getting triggered, and because of which it is trying to call that and to get it. Okay, so I can also tell print current. Print current in not in no symbols in current state. Okay. So basically we can put it. Let me continue this. Basically it's hitting this breakpoint again and again. So let me do a single step now. Okay. So like this, and it's very slow because this is happening on the if you look at it, this is happening on the serial port. Okay, so since the serial port is slow, and I can also print this timer information. Okay, I get to know what is a timer, what function it is trying to call, what is a callback function, what is the timer that has been put up here. Everything is available. Then info breakpoints, I can check out which breakpoint is available. Okay, and if you want, we can disable the breakpoint also. Break one. Okay, so info break. Okay, so basically all these things are available, and we can debug at any point of time. Okay, so all these things are possible and we can debug. Okay, so if I give continue now, and it will obviously take some time because reason is this is all this are happening on the serial port. Okay, so then if I give continue, if I check out, it happened on VFS write. Okay, somebody is trying to write, because of which the VFS is got crashed. If I check out what exactly happened, backtrace. Okay, so this is because if you remember on this particular port, on this particular thing, I wrote echo G is equal to something. Okay, and so because of which it called triggered syswrite, and that is still active. So that is the reason it has come up to this VFS write. Okay, and if I check out, it tells what file it is. It gives all the information about the file, what buffer it is. Okay, so all those FD also I can get fetch the value of FD also. Since the kernel is optimized, I'm not seeing much information, but all the information whatever I can see, basically I can put breakpoint wherever we want and we can debug. Okay, so now also it is hitting that particular breakpoint. Okay, so basically you can put a breakpoint wherever you want, and so and you can debug. Okay, so wait, let me disable all breakpoints and put a breakpoint only at the desired point, and so that we can debug and we can see what is really going on. Okay, so let us delete all breakpoint. Yeah, give me a second. I will delete all breakpoints. Okay, delete. Yes, so I've deleted all breakpoints. If you see breakpoint, there is nothing here. Okay, so what I will do is I'll give a breakpoint on VFS underscore write basically. Okay, so basically when somebody writes, it should stop. Okay, so if I see info break, there is only one breakpoint. I will run this now continuously. Only if there is an action on the some write action, it will stop. Okay, so if you see here, it has come here. Okay, so now once I entered something, it's giving some particular action. So to see what really happened, I can come out and see what happened here. Okay, so the reason is each time I enter, it will be doing the same action again and again. Okay, so I will just give continue to this again. So I want this to go off because I gave multiple times enter. That is the reason. Okay, So that is the reason that it got the same enter again. So what I will do is, so each time any activity is happening, it is triggering the same. Basically, somehow it's printing the same message, and it's basically it's stopping now in this kernel, and we can see that some action is happening here. Okay. So H, okay, or okay. So basically, it's whatever messages moment I tell control should be given to the GDB, right? The any action on that console, it's not happening. If SSH was done, it's happening. If you see here, for example, H I printed echo. Echo is the message what I printed there. Okay, so it is showing that message, and it is stopping there also basically. Okay, since I've enabled sysrq, it I have stopped, and it is showing all those things there. Okay, so now I can print enter here echo. So give me a second, and so let it continue. Okay, now it is writing the messages, and you will see that particular nothing coming up there. Okay, so basically the whatever action I'm doing on the kernel, everything control I'm getting over the GDB. Basically, if we have some breakpoints, we can put a breakpoint and we can debug it. Okay, so what we will do is we'll go to LXR Linux, and we will set some breakpoints where normally all these things happens. Okay, so what I will do is I will put a I'll put a breakpoint on Jiffy's. I think that is the best place to put it. Okay, so I will stop this now. Give me a second. I think I will do it now. It has stopped. Control G. Okay, so what I will do is I will put a write or a watch. I'll just put a write watch on Jiffy's. So moment any somebody stops on Jiffy's, it should show info watch. So one breakpoint is available. I'll give continue now. Could not insert hardware breakpoint. You have requested too many hardware breakpoints. Command aborted. I have put only one hardware breakpoint, right? What really happened? Delete. Yes. I think it's allowing only one breakpoint. So I will tell watch Jiffy's. Continue. Oh, you have requested too many hardware breakpoints. Why? It is only one breakpoint actually. Okay, so delete info watch. Oh, it's only one breakpoint. Let me delete even that. Yes, info watch. So there is no watch point. I will tell watch one, and let me set that Jiffy's. One Jiffy's. No expression. Okay, but somehow I think this particular GDB, this particular simulator is not allowing the watchdog breakpoint. Okay, so otherwise we could have seen that basically. So that's the reason we are not able to see it, but we will check out which is the right place to do it. Give me a second. Actually, let us go to this kernel and schedule. So schedule. We will put a breakpoint at some scheduler actually. So what is the message entry? Schedule.h. If you remember, yesterday we did some analysis. We can look at that log. I think that will give a complete information. Root su minus, okay, test view tester.log. This is one thing what we did look yesterday. We will look at something which was called more frequently as CHEDUL schedule. There is already a schedule function directly. We can put a breakpoint there only. Give me a second. Okay. Delete. I'm deleting all. Break. Schedule. Yeah. Now there is a breakpoint at schedule. Info break. Yeah. So there's a breakpoint at schedule. Okay. Now if you see, it's scheduling now, it's stopping at that scheduling thing. Okay, so I can see what is the list of the function. I can just look at the list and find out what really is happening there. Okay, so we get to know that why it stopped there. Okay, so now we can check out the current thing also. Okay, so I will tell print a task. Okay, so it is task struct. So we will print content of task struct. Okay, so it is printing the complete content of the task basically. Okay, it tells what state it is. Okay, then it also gives the information about PID of that also. If you remember, this is bit we can if you remember, there's a variable called com as a part of this. Okay, let us see that down. Give me a second. But basically this task struct is too big actually. If we know that variable directly, we can print actually. Hmm. But
Actually, thread info, from the thread info only, it is pointing to the task struct, right?
yeah, yeah, yeah,
Normal
true, true, true.
case.
Because everything is a thread. For that, everything is a task internally.
So that thread info structure is like a small compared to this, right?
Yeah, yeah, yeah,
Limited
yeah,
in.
yeah. Yes, 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 true. But what we are referring is the task struct at this point, and this is the current task struct. What is executed?
Okay.
Okay, so now what I'm, because the reason is this task struct is so big. If we do the same thing via debugger like Eclipse or something, right, you'll be able to see the good amount of information. But here, since I'm doing via command line, uh, the a lot of things are jumbled up here. Okay, so because normally all this information, you have some variable called previous and current. Okay, this is let us not take this. Okay, thread group. Okay, fine, fine, this is not the one. Start time, this is not the one, because there is a variable called com. Inside that we'll have a name. This is the one. So this is the thread that is getting scheduled. Soft IRQD. Okay, so this is the thread that is getting scheduled. To find out the PID of this, there will be a variable for PID basically. Okay, let us see this only for time being. Okay, so what thread is getting scheduled? Okay, so I will just quit it now. So I've quitted it. So what I will do is print. I will print current. Let us print this whatever variable we were printing. Give me a second. Print a task. Okay. So what I will do is print task using pointer com. Okay, so I got to know what is the thread that is getting run. So I will run it again. So again, it has hit the breakpoint. So let it come to this. So then I will print again what is the task it is running. Again, now it is K worker is getting running. Okay, so I will run again. So it has come to a point. Basically, this is the thread that will be scheduled now. We will see which thread got scheduled. Okay, so it is K worker again. Okay, so then after that I will continue again. Okay, so then we can see what the thread got. If you check out here, it is nothing but sh. Sh is the thread that is running. Okay, so like this, we can put a breakpoint at any place wherever we want, and we can debug. Okay, so this is via all this thing, and this is very slow because all these things are happening via serial console. Okay, don't worry about that. But only thing is that you'll be able to take the complete control via GDB even if your kernel is crashing, and you can debug anything. Okay, so same thing can be interfaced via a debugger like Eclipse, and you can take the complete control and you can debug. That you can do it. Okay, so that is not an issue. We can do that, and we can debug. Okay, let us see if we can do the same thing via Eclipse. Let me exit now. Okay, now this guy would have exited. So now if you see here, this guy has come out of the thing. So let me stop it. Control Alt G. Now we'll take a control by Eclipse so that we know how to take the control via Eclipse now. Okay. So before starting, let me start a Eclipse now. Eclipse. Because Eclipse is a good front end and we want to make use of it. Okay. So for that, let me do this now. And so let me launch it now. So it's starting. Give me a second. Let it start. But I have to make. Yeah. Pardon?
Sorry.
Yeah. Tell me. You were telling something.
So which is the convenient way? Like, so initially here we check the function graph. So if you want to check the function,
Yeah.
so first check the function graph using the other tool and then put some breakpoint in
No.
the.
I saw the function graph because reason is I wanted to debug. I want to know which is the function that is getting more frequently called to stop it and to show you people. Okay. In
Okay.
case if you are doing developing, right, you will obviously know which part of the module you want to debug. Obviously.
Uh-huh.
So assume that you are writing a USB driver. Okay, you know what all functions you have written, right? Obviously, the issue comes, it will come in your function only, right? It will not come in the existing functionalities, right?
Okay. I mean, in case some random issue.
Random means you have to see something like this. Yeah, for example, what there are two ways basically. Assume now you want to debug the scheduler. Okay, so what I put is I put a breakpoint in schedule because I know schedule is the function which is get called all the times. Okay, in case if you assume that you want to do a file system debugging and you know VFS is the entry point. Okay, so what you need to do is you need to go to the VFS and check out what all functionality is available for you to debug. Okay, so for example, assume you go to file system and you go to VFS because all the parts will be available in the VFS. Okay, so we'll come to this VFS. Come to a second. We will open the VFS. 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 Where are all the VFS? Yeah. No problem. So all this VFS logic is available outside only. Okay. So let us assume that I will take any of this particular FS open, basically FS struct. Okay. So let us open VFS underscore right. At least I know what is VFS right. So we will put a breakpoint there and we'll navigate from there. Okay. So in this, this is the function like FS read write. These are the common functionalities. Okay. If I come here, so I will get to know VFS write is an entry point which any write happens, always it will come to VFS write. So what I can do is I can go to this function. In this function, I can put a breakpoint at particular offset wherever I want and I can debug. Okay. So if I want to debug the VFS file system, else assume you want to debug a specific file system only altogether. Okay. So what you have to do is you have to go to that file system and check out what functionality you want to debug. Assume now you want to debug I want to debug VFAT. So what I will do is I'll go to VFAT, basically FAT file system. Give me a second. FAT. Okay. So all VFAT will exist in this. Okay. So all the VFAT code is available in this. So I'll go to this file.c. Okay. So now I know that all the file system activity will happen to this. Okay. So assume that I want to debug some specific write operation or a read operation. So let us go to the write calls inside this. So this is the call that will be called when the write happens. When LSEC happens, this is the call. When the read happens, this is the call. Okay. So assume I want to debug the write operation. What I'll do is I'll come here. So then I will know this is the functionality. Okay. So I will take this functionality and I will put a breakpoint like this. It depends what you want to debug. Okay. So why I looked at that log is I wanted to know which function is called more frequently and that too related to scheduling. That is the reason. But if you know LXR, right, you can put what functionality you want. You can go to that folder, you know which functionality you want to debug. You can put a breakpoint inside this GDB here and you can debug that is fine. That is not an issue there. Okay.
Okay. Yeah.
So it all depends on what we want to debug. Okay. So now let me configure the debugger for Eclipse because for better debugging capability. Okay. So let us open the debug configuration. And I want to do an remote debugging. I will take a remote application. Okay. So then I will give some name to this. I will name it as test. Okay. Then what I will do is I will browse the application what I want to debug. So that is nothing but QEMU VM Linux. This is the one I want to debug. Okay. Now I'll go to arguments. I'm not passing any arguments to that. And I will go to debugger. I don't want this GDB. I want cross-compile GDB to be used. I'll come here, bin, and I will select this particular GDB. So my GDB is set. This is set. Okay. So everything is available now to debug basically. Okay. Now after this, what I need to do is basically if you come here, so this all these things is done. So I have set the necessary things for GDB debugging. For select, I have selected a normal thing. Okay. So this is fine. So basically I've set all the necessary parameters for debugging. So this is also fine. So if I check out here also all the necessary parameters, and I need to go to GDB server. Okay. So I need to tell which port it will be running. So I'm telling the GDB server path is GDB server. I'm telling this is the GDB server, and I'm giving the path what I want. I'm telling the port number is 1234. Okay. So I'm giving this port number. So everything has been set and I'm applying it. Okay. So before doing it, let me start this now. So this will be waiting to debug. Okay. So what I will do is using this, let me connect to that debugger now. Oh, 1234 is already in use. Okay, fine. Something happened there. Give me a second. I think the debug configuration is wrong here. Debug configuration, because it started with something wrong here. That we need to stop. We'll go to this debugger. Debugger is correct. Everything is set correctly. Then after that arguments, all the things are fine here. Just give me a second. Then debugger, all the things in debugger is perfect. But somewhere I think we missed basically. This is also fine. Where did we set that particular thing actually? We set a remote debugging. Where did we set? I'm not able to see it now. Use active. So how come did we miss GDB server settings? Okay. So remote server, GDB server options. Okay, GDB server options. We should not set anything here. So this is not required. Main. So I am using this. Okay. So let me start this. So yeah. So all the things has been set now. So GDB server, and I need to tell I don't want GDB server. Give me a second. Non-stop GDB force this thread automatically detach the process for okay trace point normal. Okay, so now let me debug now to see if it's able to connect to that particular thing now. This guy is trying to connect. That's the problem. Configuration. What happened?
Maybe we already connected to
No,
this.
I think no, it is not connected. The reason is if you check out here, right? What is happening is everything is fine. It is loaded, everything is working fine, but it is trying to run that particular thing. Actually, that is the problem now. If you check out, right, it is trying to run all those things. This is the place basically. So it is trying to run it. That is also one of the problem. What is happening there? So which is wrong actually. That should not happen. Because in the current console, right, it is running the program, which should
Okay.
not happen basically. So that is also the problem. For that, I think we have to stop the GDB. We should stop not GDB server not to work. Let me try this. If this guy can handle it, debugger and the GDB. This is fine actually. Let us connect via this only. Let us see what really happens after that. Then while connecting, I'll give a different options and try to connect. That's fine. So what I will do is I will delete it. This, let me not use this. Let me use this only to debug. I'll create a new configuration here. Then I'll rename it as Okay, that's fine. Test, browse the application. So my application is VM Linux. I'm running VM Linux. Then after that, my debugger should be different. I will select the different debugger in this case. So the debugger in this case will be this bin and GDB. Okay, so this is the one, and I think with this, I think it should be able to start using that GDB. I suppose it will load now and it should work. So now I will apply it and I will run for debugging. So basically it should load and it should start. Give me a second. Did it start? Okay. So debugger, where is the debugger? Yeah. So it is it's running now. Okay. Launch encode or debugger backend, try up that. Okay, fine, no problem. That is fine. Okay. So now this guy should stop. This guy stopped basically. Oh, what happened? Let us run this again. Yeah. Debugger console. Failed to execute mi command. Details. Let us see. So exec command help target. Okay. Unknown message. Try help target. Failed to execute mi command exec run. Okay, I think it is trying to run. Give me a second. Debug configuration. We have to stop it not to run. Debugger. Software slower. Non-stop debug. Enable debugging for trace point normal. We should break on stop and startup script. Stop and startup at. Okay. So this is not available and basically share library. This is fine. Non-stop request, non-stop GDB, reverse debugging. Okay. So now I think it should stop. Here also it is default. We go to main, auto build. Okay, fine. Let us check out at least this. Basically, it should not run. It should stop because later I will take a control. It should just load the symbols and it should stop. So that is what I want in this particular case. Okay, so it is launching. Now, what I will do is I think something is going wrong here. I will look at it later. Something is, I think some configuration is going wrong with respect to this. Else, it should have worked actually. Attached your application. It is not working actually. Okay, look at this. We will. I will just show this later how to do via GDB because somehow this configuration is failing. I will just explain you later because all these things are fine, but somehow it's executing the program. It should not. It should not do it actually. It should not do. If somehow we can stop this from running, then it will work. Launch in background, terminate, allocate the console. Okay, favorite debug. Run debug. Okay, local file. Okay, shared file. Okay, I will just have a look. Something went wrong here. We can have a look. Give me a second. Let us. I will check out Eclipse. Yeah, just give me a second. Remote debugging. This is fine, and after that, okay, we will go on where IP address. Okay. Okay, I will just check out. I think something went wrong here. It's not able to. Because normally it should have stopped, but something is happening there. It is looking for some SSH and it is failing. Okay, so I will just do it. Eclipse remote debugging. It's not working. Debug configuration. We will check it out actually, because the reason is what is happening is it is starting the it is trying to run the program. For example, run. Want that interview startup operation. For example, run. Warning: some commands in this file may interfere. Warning: some of the commands in this file may interfere startup operation. For example, run. Is there any run here? No. No stop mode. Enable reverse debugging. Force thread to suspend. Okay. So I think something is happening here, because of which it's running basically. Shell library for stop and main apply debug. My command. Error in launch, file launch actually. Okay, a second. We will just have a look at it. Okay, I will just have a look at it later. We will continue further because the reason is it is tried to fail actually. Okay, fine. I will just look at it and I will show you, because this the only reason I wanted to show is in Eclipse you can get you will get a complete information, which is very good, and that I wanted to show. But somehow this Eclipse is not allowing me to do that actually, because somehow it is failing always, and it is somehow the configuration is wrong somewhere. Attached to an application of container contain launcher. Close. Okay, contain launcher. Argument container connection. Main function debugger GDB init. Okay, main will automatically argument container. This is not correct actually. I think something is missing here. So I will just look at it and I will just let you know. Okay. So one thing what we got to know is via KGDB, basically using GDB, you can put a breakpoint wherever you want, and you can debug your remote applications the way you are doing it. Okay.